Dear world, welcome back to LeetCode problem 145. So we'll be understanding the post-order traversal. So we all know that actually in post-order traversal, the way of visit is first we visit the left node, then we visit the right node, and then after processing the right node, we visit the root node. So this is the way how we visit in the post-order traversal. First the left side, then the right side, and then we visit the root section. Then we visit the root section in the third. So how we can process this tree? So for our first step is to create this one. We have to create this tree. Our second step will be to provide all those inputs, and our third step will be to get all those outputs. So first we have to create this tree. So let's start creating the tree. Okay, I've already created the tree, so let's remove so that you can understand. So to create the tree, first we have to create the pointer. So I have created the pointer tree node root pointer here. After creating the pointer, we have to create the object of that class. So creating the object solution so one new solution. Okay. Now we have created the object. Now we'll be creating the root data. So solution1.root that is equals to tree node new tree node that is 1. After we have created the new tree node, observe the right side. There is 2 in the right side of this root. So we'll be inserting the root one, solution1 dot root dot right new tree node. So we are again creating a new tree node with the value of 2. So of this right, of this 2, there is a left node. So we'll be now assigning in the left solution1 dot root dot right dot left, because in the left side new tree node 3. So okay, now we have created the tree. Now what we have to do, that input is this. We have gotten the input. Now we have to pass the input. That is, we have to call this function, and after calling this function, look the return type. This is the return type. So okay, that will be the return type, and we'll be storing the return type as a result. Dot solution1 dot post order traversal. So we call the function post-order traversal. We need to pass the root. So let's pass the root solution1.root. Now we have passed the root. Now we will be coming in the main function. Here what we have to create, we have to return all the children output. So there is output, and the output is of type list integer. That means we have to create that list. So let's create the list integer result new array list. So we have created the list by now, and what we have to do, we have to just return the list or result. So return result. Okay, we return the result. Now we have to implement the function, that how we will be adding the elements. So for that we'll be utilizing or taking help of another class, and let's call it post order helper, and here we'll be passing the first root node, and the result where we'll be storing the data. And now let's call the function, and for that we'll be initializing this as private function, private void post order helper, and then we will be capturing the root node tree node root, and then we will be capturing the result. So list of integer result, as you can see. So now we'll be implementing the function. So just try to observe that what will happen, that now this is the tree we have. So what it might happen, that we'll be getting two cases. First, when in this section that we have a node, the case might be we have a node but the node is empty, and the second case, the node we have gotten, this is one which is being pointed by the root, that is being pointed by the root, and that is the left section, this is the right section where there is two, and of this right, in the left there is, three. So that this is the section, that is, there is two cases. The first case, the case 1 is when we get the null. This is the case 1 when we get the null, case 1. And the second case is when we don't get the null, case 2, not null, case 2 not null. That means this time we will not get null. So we'll be dealing and handling the two cases. And now observe, what is binary tree traversal that we will be processing or adding. This is, we have to first process the left, then right, then root node. So we will be just adding the root node at the end. So we have to add the node, because always the root is added or printed, and left and right, these are that run in recursive manner. So these will keep running in recursive manner. In recursive manner, those will keep running. It will keep running in the recursive manner once you apply the recursion function. So let's apply the function. So void post order traversal. So we'll be checking the null case, that if root equals to null. If root equals to null, that means there is no element. Return, just return. And now if root not equals to null, then we'll be checking the other cases. First, we have to check the left one, post order helper. Now we're processing the left side, root dot left comma result. Okay. Now we'll be processing the right one, post order helper root dot right result. Okay, now we have processed the right one. Now we'll be processing or adding result dot add the data portion, root dot val, because we call val to the data. So let's see if it runs or not. That's telling we got some error here. The error is we have utilized a third bracket here, so silly mistake. We always have to use the second bracket. Typing mistake. So again, let's run. So as you can see, our program has been accepted. First, the tree node was previously being created, so we don't have to create the tree node. If the tree node was not created, sorry, I just forgot to change the screen. If the tree node was not created, then we have to create. So we check the first condition. If root was null, we return. If root was not null, then we just process the left section, then we process the right section, and then we added the node, and it just worked. So meeting in the next video.